All right.
Hang on,
And
hang
we're
on, hang on. Let's see. I gotta push go live twice. Once on the LinkedIn also.
That's good. Real safe.
All right. I see we're live on LinkedIn.
super. All right. Welcome everyone to the first episode of This One Time. And we're launching this podcast from the offices here at Urban Machine. My name is Andrew Gillies. I'm the CTO and one of the co-founders of Urban Machine. And this is Sasha Glisky joining me today in the office here. He's on the hardware team. And we also have Jory Wisniewski.
You got it.
Jory, I will get it right one of these days.
It's just how it looks. I
Yeah.
mean, it's the three syllables. They're scary. I understand.
Yeah, and Jory's joining us from Chicago. She's heading our marketing efforts here at Urban Machine.
That's right.
Yeah, and I thought since this is the first episode, I'd go a little bit into why we're doing this. I've been in hardware development, mostly in robotics, for just about a decade now. Various levels of prototyping, launching products, either consumer or industrial applications. And what I've noticed is that, especially in hardware land, it's no secret that hardware is hard. What I've noticed is that you tend to see the output a lot of these developments, that slick, glossy video or that demo that's all polished and ready to go. And you hear that hardware is hard, but you don't often hear about the hard stories that get you there, those challenging times, those late nights. Like, what was actually happening in the nitty gritty? Like, why is it hard? We decided we wanted to share some of our stories of the challenges that we've been through at Urban Machine in the last year and a half. And really, the idea here is that we could open a dialogue about the actual challenges. Through my decade of doing this, I've noticed that a lot of us, unfortunately, are solving the same problems over and over again. There's a lot of repeat work. And there's a lot of really incredible missions that people are working on here. I think what we want to see is that everyone is succeeding along their paths. So if we can put some of this information out there into the community and develop that conversation, hopefully we can help everyone get a little bit closer to the goals. Maybe we can learn some things from the community as well, so we can avoid problems that we haven't run into yet. And really just like let's just move down the field together. Let's get some of this stuff out there. You know, a lot of the challenges that we faced are not on the proprietary aspects or the core aspects of our technology. They're just silly little platform things that everyone is fumbling on. Why do we all have to do that?
Right.
Software has a really great track record of putting open source projects out there. You can go and you can learn a bunch on Stack Overflow or on GitHub. And there's not as much of that in the hardware community,
Definitely not.
right? Like it just feels much more siloed. So we're going to kick this off. We're going to start doing these episodes here. We're going to share our stories, but you know, this is the first one of these. We might evolve this in the future to start including other folks if they're interested. We're really just, you know, the mission here is really just to like share and build a community around these hardware challenges, especially with folks that are working on these like really great missions, trying to solve some of the big gnarly problems that we're all too aware of these days.
Right.
Yeah. So
Actually,
that's
Andrew, if you remember, the first time I met you guys all in person, I went around and I was talking with each of you for like a half hour and asking you questions. And each of you had some story about this one time this happened. And it was like this catastrophe. But we recovered. And I was like, you guys have a story to tell. Like there are many stories to tell. So
Do we all have different stories, or did we have the same story we told from different perspectives?
no, that is exactly why I thought this would be a good show because I did not hear the same story twice.
Good.
There's lots of stuff that goes wrong, but there's also, that lesson of you overcame it. So,
Definitely.
Yeah, absolutely. And we'll try to hit on a variety of these things, and each of these stories we'll try to generalize it as well and kind of pull it out of the urban machine context. So hopefully for folks riding along with us that there's some sort of nugget that they can take out of that, some sort of either challenge or skill or some sort of conversation they can start within their own organization that applies to them. So we'll always try to do our best to kind of pull those generalizations
right.
out of the story as we go.
Yep.
And then this first one is Grace Under Fire. How
Yeah,
did
yeah. So,
you
so
handle
today
it?
we'll be talking about Grace Under Fire.
Mhm.
And before I get into the details of the story here with Sasha, I'll just set the stage a little bit about what we're doing at Urban Machine. So at Urban Machine, we're tackling the problem of waste lumber, specifically from construction and demolition. In the U.S., every year, around 37 million tons of lumber is sent to landfill. This is like staggering mountains of lumber that we're more or less shredding and burning every single year. And we want to find a circular story for that material. We want to create more sustainable systems for our built environment. So we're creating a large robot that can ingest this waste lumber, find the contaminants, find the metal fasteners, find the pieces of the puzzle that are causing it to be in the waste stream, pull those out, pluck it, sort it, so that we can enter it back into the lumber industry and sell it again as an intact high-value material. So the Urban Machine robot is a large system. I think we're closing in around 80 feet long for a processing line.
Yeah, probably.
At this point. Yeah, it's a large device. We're using cutting-edge robotics, perception and manipulation technology, and we're gonna get into the juicy details of that. Yeah, we've been at this about a year and a half now, and the story that we'll tell today happened. That was July last summer.
2022.
And at that point in time, we were just bringing up the first full-scale prototype.
Yep.
So that's kind of where we were. We had gone through some benchtop tests. We had some early concepts of how to tackle this problem. And we were just, we were kind of like that lights on moment on that first prototype. Now, at the same time, we're in startup land, so there's always that, you're looking for that next fundraise, right? That next milestone. And in this case, we were starting to stack up investor demos. Yeah.
And for context, I came on board very, just maybe a month or two before this happened. So very much I came into this half-built machine and was just given things to be like, here we have this, make it better, fix this, go on to the next version of it. So sort of very much thrown into the deep end, and how do we get this thing actually working properly?
Yeah, there's only a handful of us working on this large machine, so it's like, all hands on deck.
And you were number 6, right, Sasha?
Number 6.
You were number 6. So you had something to prove also.
Yeah.
Exactly.
And so we're working on the machine. This is the closing hours. I think it was like getting later into the evening, and big demo the next morning. This is one of those demos where you just really, really want everything to go well. And anyone who's done hardware and especially robotics demos knows how fraught that is, especially for a prototype. It's just really, so the number of things that can go wrong, it's a long list. It's very intense.
And for some reason, it just happens that the more important the demo is, the more likely something will go wrong.
Yeah.
Just the way things work.
Yeah.
Yeah. Somehow that's how it plays out. Yeah. So a little bit about leading up to this. I'll have to describe the machine a little bit. Our system involves 3-axis gantries with an end effector on them. That's what we use to go in and grab onto fasteners and pull them out of the lumber. That end effector on our first design was a large pneumatic cylinder. It was a 5-inch bore cylinder. So this thing, at 100 psi, I think this can do like what, 1,500 pounds?
1,500 pounds is
what
I remember.
What you worked out, yeah.
Back
Yeah.
so
So like this thing could lift up your car, right? Like extremely powerful actuator, and it's sitting on this ball screw, stepper motor driven ball screw gantry, so we can position the cylinder in order to do this pulling action. And maybe Dre can share.
Right?
Yeah.
We came prepared.
Yeah.
I would expect nothing less, Sasha.
Excellent.
Yeah. So here it is. Here's Sasha cranking away on some wiring. This is like in the weeding hours before one of these demos.
What's playing in your headphones there? Do you remember?
Just white noise and static. No.
Yeah. Screaming.
It's just screaming. Yeah.
So you can see that here's the pneumatic actuator, and here's this ball screw assembly. And I think I actually have a quick clip of this so you can see some motion here. So you can see one of the pieces of lumber we're trying to recover on this shuttle system. So these kind of travel back and forth past our gantry, and we have this little picker system here that can go in and grab with this pull action here. So the key item here was this ball screw. So this is what moves that cylinder back and forth. Now, I think it was literally that evening before the big demo.
Yep.
Alex, who's leading software efforts and also the third co-founder at Urban Machine, was actuating the system probably for like one of the first times he's teleoperating at this point, and accidentally fires off that pneumatic cylinder while the shuttle was right in front of it, right? So it was like a giant piece of metal there that is not going to budge.
Yeah.
And now you have 1,500 pounds bearing down on it.
And this shuttle was you designed this. You spent 3 weeks designing it and building it, so it's not moving. So something has got to give.
Yeah. Something has got to give, and unfortunately, what gave was this cast assembly here. This is the motor mount. So on this face here, that's where the stepper motor attaches, and then the ball screw is housed here. Yeah. And this thing just shattered. It came like the cylinder came back, hit the back of this plate, and you have this circular, this cross section here is circular. That's where a fastener comes through to bolt it to the support plate. Stress concentration right there, and this thing just blew up, just completely blew out the back of the thing.
And I was surprised personally because in this world of hardware, you expect the things that you design are the ones that are going to break. As opposed to the thing that you get off the shelf that you'd expect to be sort of a reliable piece that sort of is a given. Did not expect this thing to just pop off. And I remember sitting working somewhere and noticing the rest of the team sort of congregating around the machine in one spot. And if that ever happens, it's usually something bad. It's something that's it's not a good thing to see.
Yeah, you never want to walk out on the shop floor and see the whole team huddled around one little specific spot. It's like not good. It's not good news.
No.
Right?
That means bad stuff's happening.
Bad stuff is happening.
I'm sure the facial expressions also were helping.
Yeah, there's probably a lot of this, right? There's probably a lot of this going on. Yeah.
I do think we do a good job, again, tying into the whole Grace Under Fire. I think the whole team, I don't think we have ever seen anybody panic.
Yeah.
I think it's more like immediately sort of where do we go from this? This is the reality. What do we need to do to fix this?
Yeah, absolutely.
We have a demo. What do we need to do? It's immediately like triage and sort of crisis mode.
Yeah, and also safety is always on our minds, right? Like usually when these events happen, there's this urge to jump in and try to intervene, but the first thing is is there any hazard in this situation? How do we reduce hazard? How do we release any stored energy in the system before carrying forward? So whenever some event happens, it's really important to just sort of take a step back and make sure that you're not about to injure yourself, right? It's so easy to want to reach in and do something.
Exactly.
But reducing the hazard, make sure that nothing is going to pop on you.
Mm-hmm.
Do you handle situations like that in your real life? Are there emergencies? Are you that calm and collected? And
what would you say?
You seem good at it. Are you just like
I think I don't have a great poker face, but I think it's just good enough to hide the level of anxiety and sort of panic that I feel. Again, work or my personal life, it's the same.
Okay.
But I think this time I managed to put in a sort of brave face, mostly because I sort of had to. It's the early days for me, and as we said, we have the whole triage mode, and it fell to me to find a way to fix this thing.
Show them what you're made of?
And find a way to make this work. And again, the very important thing I've learned is that good enough is very, very important. It just needs to work for the demo that is happening in 12 hours, 8 hours, however long we had.
Okay, so you put your thinking cap on, and what happens?
Yeah. So a couple other details of the device. So obviously this component is a critical component. We're not running this nail picker without this motor mount, right?
Okay.
We are dead in the water at this point.
Mm-hmm.
And we happen to only have one of these in the shop. Now this is not an expensive component. This is something you can buy from Amazon for $80. But no matter how good Amazon's shipping are, they're not going to get it there that night. Which we just needed. We needed something that night. What we did have is a whole second nail picking unit. This was another approach we were taking to nail removal. You can kind of see it in the background here. It was called the rake, and instead of precision picking the nails, it would kind of reach in with a simple mechanical action and just grab and pull. So it was just kind of going up, like that.
Okay.
And that was the one that Sasha was actually working on. So Sasha's chipping on this one. He was actually just working on the rig. So you're just pitching in on this one. We happen to have this exact same ball screw mechanism on the rate.
Yeah. The only other one
we had in the entire shop was on the rate. Now, because of some details of the mechanism and the geometry of some of these mount plates, we decided, and how critical the precision picker was to the demo the next day. That's really what the investors were interested in seeing. We made a decision to rob the rake, to disassemble the rake, take the motor mount off of that one, and then put it back on the nail picker.
Yeah. Mm-hmm.
So pretty much we're taking Sasha's great rake mechanism, and we're just like, okay, we're shutting this thing down.
Right.
And
That's
now
as impressive as the nail picker, so it's out for today.
Yeah, it's out for today. But that's when Sasha sort of stepped up and said, like, well, does it actually have to be out? And you sort of saw a pathway forward there.
Exactly. Yeah.
Yeah.
We don't, or didn't, and still don't have much stock of components in the shop. Like and especially back then, like I'm not sure what the budget was, but it wasn't massive. We couldn't just have all kinds of components lying around.
It's tight. It's early days. Yeah.
Exactly. And like maybe there's another argument for should we have prepared for this, but the reality was that we didn't at the time. So, but what we did have was every former sort of custom part we never threw out. We just put it on the shelf into the graveyard.
Yes.
And we all use the same motors. So I went digging and found this large metal plate from like a former failed experiment. But all I needed was just like something to, like a little flat piece that I could mount to the back side of this component to hold on to be able to mount the motor onto it. Now we could always like take a drill and drill out the holes, but I mean this is like 1/4 inch aluminum plates, and the holes are pretty big for the motor to go into. It's like I could have been there like all night with a drill trying to just chisel or drill or chisel away some very crude thing.
Yeah, you're talking about removing like maybe a 2-inch diameter chunk of material out of this plate.
Exactly. But there was one part that had that exact cutout, and I think I just went digging and found it. And it had that exact mounting part, the sort of that matched the face of the motor perfectly because it was designed for the same motor. And all I had to do was just basically, and it didn't even have like a slot and a few mounting holes that were used for something else, but that was enough for me to work with. So
this is like the ultimate Lego piece.
Exactly.
Like, there it is.
Yeah. It was maybe like the straight block in Tetris.
Exactly.
But I had to cut it away from like the 20, like a much longer block in Tetris if those existed. But I literally sat for 30 minutes just cutting through this thing with not a JAXA, but the reciprocating saw.
Yeah, reciprocating saw. Yeah.
I had two that I would switch between them because they were getting so hot from just how much material I'm cutting through. But eventually managed to get a thing that just fit on the machine, and I could then drill a few holes into it to mount it with an angle bracket. Again, we have flat pack, sort of flat metal pieces from previous projects, and we have off-the-shelf angle pieces. So
you found the best one that would work, and
yeah, exactly. And this whole time, I'm just thinking, I need this thing to work because we do want the full demo. Yes, we have the rest of the machine, but this is like still part of like what we want to demonstrate. So I'm thinking, how do I do this? How do I do this? Damn, I thought like maybe, there we go. But straight face, didn't talk to anybody. I don't think I just sort of got to it and just sort of literally just spent a couple hours assembling this thing. And
so like what time of night is this at this point when you finally finish digging out the metal and you fix it and everything? Oh, okay, I see it now.
Yeah, it was late enough that Andrew takes out his we've had dinner and Andrew takes out his speaker and starts playing Red Hot Chili Peppers, which is a signal that this is going to be a late night.
Yeah, that's a signal to the team that we're in battle station mode. The pizza shows up, and truly.
It's good amp music.
Yeah.
Yeah, but yeah, definitely got it done in the end. As you can see, I was hoping to actually bring it here, but I don't really have space on that. Sorry, Jory.
It's
But
okay.
it worked, and not only did it fit, and we could even adjust it, and it held. I think it stayed on the device for the rest of, well, for as long as we had this version of the machine.
Yeah, this hacked in piece lasted for like another 4 or 5 months, something like
Right.
that. It was so good that yeah, there was no point in going back and changing it. Like, okay,
Yeah.
it's there. It is.
Yeah, it's doing its job. Now, when the investors came, did you feel like it was an eyesore, like it was the red nose on the thing? Like, even though you know that they're not going to see this one little piece that's crooked and,
I think a lot of these details, like we see all the grungy little details. Like you'd be surprised about folks coming through and watching the demo, and like they're so dazzled about the core action, right? Like the nails coming out of the lumber. That like there's major architectural pieces that they like folks coming from the outside are just sort of blind to.
right.
So I think you'd need like if someone came in here and said like, oh, what is going on here? That must have been a hell of a story. My next question would be like, do you want to work here because you have a really
Right.
keen eye for
Right.
detail.
You cued onto that one little tiny piece. That's
Yeah,
impressive.
that would be a super impressive observation.
Yeah.
You didn't ask me to like stand in front of it the whole time. I sort of just
Drape a cloth over
yeah,
there.
just straight.
Yeah.
Always
Don't
been
look
the way-
behind the curtain.
Yeah. But these are one of these things where, Sachi, you mentioned before, like just good enough. There's these systems we're working on, especially in these sort of like, people call it deep tech, hard tech problems. There's just so many little details and challenges and like rabbit holes you could dive down. You just don't have the time or resources to be chasing every single one of those things down. So you really need to be pretty ruthless in your triage efforts, right? About like, yeah, what's just good enough? What is the core thing we're trying to solve right now? Right? Like we're not trying to get to the bottom of every single problem. We're just trying to like get a little bit further down the field with the resources that we have as an organization right now. And this is a perfect example of like, yeah, we're graced under pressure. This is good enough. This gets us through the demo. This gets the machine up and running.
This gets us
But
the money.
this gets us the money, but it doesn't sink. It didn't sink our time, and it was good enough. So it stayed in place there for another.
Do you remember what time you actually left at that night or next morning?
I had to wait
Yeah.
for like 10 minutes for an Uber because there was public transport was not.
Yeah, it was
It
long.
wasn't an option
Way too
anymore.
late for that.
Yeah.
Yeah. Weaning hours of the eve.
And it wasn't the only time we've had late hours while building something, and especially it always happened around the times that we had important demos to prepare for. But I think looking back at this, I think these events very much sort of brought up some very important questions that I think are is going to be a constant discussion. One is sort of, well, one, how do we prevent this from happening again in terms of
Right.
do we keep extra stock? Do we spend some more money to save time and effort and panic down the road? The other one is also, I think, better communication across the team because we realize that not every demo is make it or break it.
Yeah.
So if this was something else, at what point do we say it's fine if this does not work because this is not the most important thing ever.
Yeah.
What's more important is get home, get some sleep, come back tomorrow.
Yeah.
Versus this might make or break the company.
Yeah.
There's two extremes. So
Yeah.
how do we judge that down the road?
Communicating that, and we end up scoring the demos internally just as a signal to the team that says like, yeah, you just can't be on redline. You can't be redlining it for months and months, right?
Right.
Like we got to know like when to push, but also when to rest.
Right.
And it's
There's that life
expensive.
balance.
Yeah, life balance and just on the team's focus, right? Like it's expensive keeping this machine up and running all the time. Like we need downtime to get these hardware fixes in, to update the software.
Yeah.
It's good to have a cadence of these demos, but you need some ebb and flow there. So yeah, if it's a friend of mine from grad school, we're ranking that pretty low on the list. Like it's okay
Right.
if my friend sees some of the rough points, and then yeah, if it's we're about to close a major deal or a customer or an investor
Sure.
at a late stage, then we want to be that's battle
On your
stage.
A game for sure, and you put
Yeah.
in what you have to. I have to tell you, I just looked. Tyler is messaging. Go back to the picture where remember when you showed me that picture. Yeah, if you can. Nope,
Yeah.
that one. You can see Tyler's legs. He swears it's not him laying down, but Tyler, I did spot you
Well, I
before
think you can. Wait, can you see him? Oh no, someone else is in the.
blocking. Yeah,
Oh, there's
you
there's uh,
can
there's
see
there's,
just a
there's
little bit.
Tyler in
Yeah.
turn. Yeah,
Uh-huh. That's
yeah,
so funny. I love
yeah.
it.
Here's another view of the beautiful hacked in. I think it was half-inch aluminum. Actually, you spent a good amount of saw blades getting through that.
Yes.
Yeah, and then
Yeah.
there's
There's,
Happy Project. There you
yep.
go. Ready
I
to
mean, I
go.
was hoping for the stash picture because it's a good one.
Yeah,
I love
yeah,
the lessons you guys learned, and I do think that it's what you guys have done in such a little amount of time at Urban Machine. You're on your fourth iteration of the machine in a year and a half. I mean, that actually teaches you something about your team, or tells you something rather about your team. And you did stay calm. You had grace under fire, and you were able to pull it off when it needed to happen.
yeah, absolutely. And it's all about, these things happen, but learning from these lessons and using that to propel you forward.
That's right.
Yeah, yeah, absolutely. Yeah, so these are the types of stories we're really hoping to share on the podcast and start a
Hmm.
conversation around, right? And just going, just thinking through like how do we face these challenges? Like when is ordering stuff off of Amazon? Like when is that, our Amazon robot, when is that good? When is that bad? How cheap and great flat pack components are, how versatile they are, how to think about demos and the importance of those demos, thinking about, yeah, when and where testing happens, how to stay calm and how to make, yeah, good decisions and grace under fire.
Yeah.
Yeah,
I just
yeah,
put our website, urbanmachine.build, in the chat box on LinkedIn so people can check out what we are doing there and
absolutely.
how
And
awesome our
we are hiring. So if you're
team is.
interested in working on machines like this or being involved in this type of work on this type of mission, yeah, just go on the website, the Jory shared there, and yeah, we'd love to hear from you.
Yeah, go to the page at the top. I have all the jobs listed. It's careers under the tab that says
Nice.
careers. All
Super.
right. Well, thanks
Yeah.
for joining us on
Thank you.
this
Thank
one
you, Jory.
time.
Yeah.
Yeah,
Yeah.
we look forward to seeing you again next week.
Super.
Yeah. You're still just sitting on the live stream.
I think so. Yeah.
Yeah.
Hanging out.